Hi, this is Rick for EDU Mobile. Now it's time to demonstrate enumerations. The word enumerate just means to count something. So all we're really doing is counting things. But Swift enumerations go way beyond counting, and we're going to see some examples of that here in just a moment. I will mention that this is a playground. We're going to be looking at our code in Playgrounds for the remainder of this unit. Unit 3, we'll start talking about mobile app development using Swift with iOS 8. But for now, I want to concentrate on just the code. So we're not going to look at view controllers and all of that stuff until the next unit. All right, so in a playground, we get an immediate output for any input we provide. It's a interpreted environment for the Swift language. A couple of things you can do. First of all, you have these very unhelpful outputs over here in the playground for the particular value of an enumeration. So it just says enum value. If you want to see what that value actually is, you can click the little eye icon over here, and that doesn't help. But you can also click the plus, which will show you that value. The case green self equals amber is what that's doing at this point. If you look at it here, we're saying the intersection is a stoplight.red. You can look at this eye and it will tell you enum value, but you can also look at this and it will tell you that it is stoplight red. Okay, so here we go. You can also close this sidebar at any time by closing with this tiny little X up here in the right hand corner. Okay, so we've got a stoplight. This is an enumeration. It has 3 states or 3 members, red, green, and amber. And we have a mutating function that will change the value depending on what the current value is. So red goes to green, green goes to amber, amber goes to red. We also have defined a member function here, or call it a method, which is just going to return a string, and it's the string representation of the current member. So we switch on self. If it's red, we return red, and so forth. And it tells us what's going to happen over here in the sidebar. All right, so we're going to make a stoplight and then change and inspect its state several times. So let's make a stoplight. We'll call it intersection, and we'll set it arbitrarily at stoplight red for this point. And then we're going to check and see what the membership is. It's red at this point. Now, if we call intersection change and then check the membership again, it'll be green. It has cycled from red to green. If we do intersection change again and check it out, it has cycled from green to amber. Of course, if we do this again, and I'll just copy and paste it, we can see here's a copy and here's a paste. We can see it change again from amber. The next state is red. There we go. So that's pretty straightforward. 2 members here. One we talked about in the discussion, or 2 methods here. One is a mutating method. Mutating, again, means I'm going to change something about myself. Notice that self here is referring to the member, not stoplight. It's referring to stoplight dot what. So stoplight at this point is red, green, or blue, or red, green, or amber. And then we can also modify or mutate self in a mutating function. That is the meaning of this keyword mutating. Modify self. All right, so now let's look at a different one. This is an enumeration that might model a logical and or gate. So what do we need? We need 2 states. We need 2 types of gate. An enumeration gate has 2 cases, and or. So we can define a function. This is not a mutating function. This was just looking at what the current state is. So evaluate for A and B and return a bool. So these are both bools. If it's true and true, we should return true, otherwise false, and so forth. So you know me, if you've been around me for a while, you know that I don't like to return from more than one place in a single function. So I set up a value called retval and set it to false. I'm going to assume that we don't have good inputs. In the case of an AND gate, if in A and B are both true, I'm going to set that return value to true. In the case of an OR gate, if in A or B are true, I'm going to set the return value to true. And I'm going to then, after all my cases are exhausted, which they are, I only have two, I'm going to return my return value. I set up two gates, AND gate and OR gate. And AND gate is defined as gate.AND, OR gate is defined as gate.OR. So now, this method looks a little funny if you really look at it. When I call it, notice that I've got two parameter names provided in this function, in A and B, but I only am using the first one, and I must use the second one. If a function is a method, the second and subsequent parameter names must be used. In other words, they are implied as external parameter names by default. And this really isn't a problem. It allows us to name our functions like they were Objective-C functions. It allows us to name our methods as if they were Objective-C methods. So this is one important difference between defining a function inside an enumeration, a structure, or a class, where it is a member function or a method, and defining a function outside one of those things. So I have named my function evaluate for A, B, so that I can call it in more or less an English language syntax. It says evaluate for A true, B true. Kind of nice, really. You can opt out of that behavior. We might go into that, but you can look that up. It's really easy to opt out of that behavior. But we can continue with what we've got here. So we're evaluating an AND gate for true and true. And that should give us true, and it does. And then we evaluate the OR for false and true, and that gives us true. Let's test what happens if we try to evaluate an AND for false and false and true. We should get back false, and we do. Likewise, if we evaluate an OR for false and false, we should get back false, and we do. So that's pretty cool. We can mimic an AND gate, we can mimic an OR gate, and we can do it in the context of an enumeration. So we have a data structure that is able to also provide functionality about itself. However, it's not a reference type, it's a value type. In other words, if we assign some other gate to AND gate, var my gate to AND gate, and then somehow change it or mutate it, if we had a mutating function, then AND gate here would be unchanged. It is passed by value. Here's an example with some associated values. We've got a shape. A shape can either be a circle or a rectangle. That's all I'm saying about it. But for a circle, we're going to need a property of shape, pi. We can define pi outside, but let's do it inside. Makes it kind of self-contained. We can use shape.pi or whatever.pi to get back the value of pi. This is called a computed property. Now, I can't just say var pi equals 3.14159 because in an enumeration, I can't have a stored property. If I just go ahead and store a value, that's called a store property. I need a computed property in an enumeration. Now, structs and classes can have stored properties, but enumerations can't. So how do I get around that? I make a computed property. This particular computed property, known as pi, is a double. And if I have called its getter, I'm going to return 3.14159. Okay. So every time I look for pi, every time I call its getter, every time I say some shape.pi, I'm going to get back this value. If you're a purist, you're saying, wait a minute, I should define that as a constant. I should say let pi double and then get a getter. Yeah, that would be the way I would love to do it. I would love to do that. But a computed property cannot be a constant. It's got to be a var. It's got to be a variable. So if I say let here, watch what happens. Oh, it blew up, right? Because let declarations cannot be a computed property. That's what I just said. So it's got to be a var. However, because every time you use its getter, you're going to get back the same value. It's kind of like a pseudo constant, if you want to think about that way. By the way, you can also define a setter for a computed property with the keyword set and then set it too. But we wouldn't want to set pi. And we'll look at more examples of computed properties later anyway. So we're kind of sneaking into the idea of properties and methods inside enumerations, which will also apply to properties and methods inside structures and classes as well. So I'm kind of giving you a double dose here. All right, back to the enumeration. This shape can either be a circle or a rectangle. These are the cases. But I want to show you some associated values. A circle has a position and a radius. The position being the point of the center. There is a CG point defined someplace, but let's just define it here. The point itself is a tuple, double, double, and then it's all part of a tuple for the circle. So the circle is a point, double, double, and a radius, double. But a rectangle isn't the same way at all. It doesn't have a center. Well, it does, but it's not interesting. It has a length and a width. These can be double, double. I use doubles here instead of floats because we tend to get rounding errors when we use floats, if we add them or divide them or whatever. So use doubles because you've got a significant amount of greater precision with them. All right, so now we've also defined a function. This is defined outside of shape. It really doesn't matter. We could define it inside of shape, but there's some syntactic hoops you would have to jump through there. But here's a function called area, which takes a shape called shape, and it returns a double. So now we're going to switch on whatever that shape is. Now switching on shape outside is going to switch on the member of shape inside. So this particular shape might be a circle or it might be a rectangle. So we need to check out which it is. So if it's a circle, we want to get x, y, and radius. They're all going to be constants in this particular case. So we could make them variables, but case let dot circle x, y, radius. The same as our signature here for our tuple definition, or tuple, whatever you want to call it. And then we're returning pi times radius squared, pi times radius. Otherwise, case let rectangle, width and height, and here's how we get those values back out. We're just calling them, in this case, width and height. We could call them Fred and Wilma. It doesn't matter. But we return width times height, and that gives us the area of a rectangle. So now let's define my shape to be a shape.circle with a center point of 2, 5, and a radius of 3. Wait a minute. Don't those have to be doubles? But they are doubles. They don't look like doubles, but when they go in to shape, and specifically when they go in to circle, they are double, double, double because they're inferred by the assignment to double, double, double. So we don't have to say 2.0, 5.0, 3.0. And then we can call area on my shape, and we get back 28.2, whatever, blah, blah, blah. Now we make a rectangle. But look, my shape, oh, wait a minute, my shape is a circle. Can it be a rectangle? It can only be one at a time. But if we reassign it, now my shape is a rectangle with a width of 4 and height of 9. And if we say area my shape, it says 36. 36.0 because we returned, what? A double. Very good. If we reassign this and it's a var, we can do this. We can say now it's a circle, now it's a rectangle, now it's a triangle, now it's whatever it is. All right, so here's another example. Raw values. Really, with Swift, raw values are only interesting because the power of Swift enumerations goes way beyond counting. But counting is, raw values are kind of like the counting thing. And you may want to use raw values at some point. So here's an example, days of the week. Now notice that when and I mentioned this in the discussion, when we define an enumeration having raw values, we need to define the enumeration of being a type that goes with those raw values. So in this case, we defined an enumeration containing the days of the week, and because I've used integer values for those days, I need to say days:"int when I define the enumeration. All right, so I have Sunday, Monday, Tuesday, blah, 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 and I have set Sunday equal to 1. Now Monday will have the value 2, Tuesday will have 3, Wednesday 4, Thursday 5, Friday 6, Saturday 7. So now I'm going to say weekday, a little bit different here. Weekday is made days.thursday.toRaw. So now what is weekday? Weekday is 5 because the raw value of Thursday is 5. Now, if I don't give Sunday a value, or if I don't give an explicit value to something before Thursday, Thursday won't have a raw value. So, it will if I make days int and do it that way. So if I do it that way, Thursday to raw is going to come out as 4 because Sunday, it defaults to Sunday being 0. So if I say days int, then Sunday is going to be 0. If I say days something else, Sunday may or may not be defined. But let's go back to the idea of Sunday being 1. Thursday, Friday, Saturday is usually thought of to be the 7th day of the week. So, yes, Thursday is raw. Now, this comes back as an optional. It is really of type int optional. So, that one's not. I'm sorry. The next one is, if we use the from raw and then give it an integer, this comes back as an optional. So we have a variable called might be a valid day, days from raw 8. So if we look at this, and Sunday is 1 and Saturday is 7, and there is no 8th day, regardless of what the Beatles said. We have days.fromRaw 8, and that's giving us back a nil. All right, let's inspect that value a little bit closer. That nil is an optional nil. Let's to avoid confusion. It says right here, var might be a is an optional nil, right? All right, well, let's say that we change that Thursday maybe. Now it's going to tell us that it's a enum value, but might be is an optional enum value. If we want to look at that, enumerations really don't give us much more in the way of looking at that. So that's not really helpful. But we have a good one here, and it's an optional, and it's not nil. Therefore, we can infer that it's probably, Sunday being 1, we can infer that it's probably Thursday. So there we go. And of course, we could write a switch statement inside here in a function that would return a string name corresponding to the day of the week. All right, so we've been through a lot of stuff, and I know this demonstration and the discussion were long, but there's a lot of stuff here, as you can see, to talk about. And there will be more with structures and classes as well. So I apologize for the length of these, but we really need to get the concept across, and it's probably better to have 3 or 4 long talks than 30 or 40 short ones. Thank you very much.